potential energy and stability. Virtual work. The previous article treated the equilibrium configuration of mechanical systems composed of individual members, which we assumed to be perfectly rigid. We now extend our methods to account for mechanical systems which include elastical elements in the form of a spring, elastical element in the form of a spring. We introduce the concept of potential energy useful for determining the stability of equilibrium. Concept of potential energy which is useful for determining the stability of equilibrium. Elastic potential energy is the first principles in the form of potential energy and stability. Elastic potential energy. The work done on an elastic member is stored in the member in the form of elastic potential energy. The work done on an elastic member is stored in the member in the form of elastic potential energy. Energy VE. This energy is potentially available to do work on some other body during the relief of its compression or extension. For more description, consider this picture. Consider this picture, a spring which is being compressed by force F. We assume that the spring is elastic and linear. Assumption. The spring is elastic and linear. Which means that the force F is directly proportional to the deflection X. F proportional to the deflection x, as shown in the picture. We write this relation F equals to, where K is the spring constant of stiffness. Spring constant of stiffness. After the work done on the spring by F during a movement can be calculated as this relation delta U F delta X in the direction of displacement, with replacing the so that the elastic potential energy of the delta VE Kx delta X. So VE can be obtained by integration from 0 to X Thus, the potential energy of the spring equals to the triangular area in the picture shown here versus x during an increase in the compression of a spring from 2.x1 and x2. The work done can be calculated by this relation. One second of which equals to trapezoidal area from x1 to x2 as shown in the picture here. During a virtual displacement, delta x of the spring the virtual work done on the spring is the virtual change in elastic potential energy and can be calculated as this relation. During a decrease in the compression of a spring, as it is relaxed from x1 to x2, the change in the potential energy of the spring is negative. Consequently, if delta x is negative, also delta V is also negative. When we have a spring in tension rather than compression, the work and energy relation are the same as those for compression, where x now represents the elongation of the spring rather than its compression. While the spring is being stretched, the force again acts in the direction of displacement, doing positive work on the spring and increasing its potential energy. Compression, positive energy. Because the force acting on movable of a spring is a negative of the force exerted by the spring on the body to which is movable, and is attached, the work done on the body is negative of the potential energy change of the spring, because the force acting on the movable end of a spring is the negative of the force exerted by the spring on the body to which it's movable, and is attached. The work done on the body is the negative of the potential energy change of the spring. A torsional spring also can be stored the potential energy a torsional spring which resists the rotation of a shaft or another element which resists the rotation of a shaft or another element can also store and release potential energy. Can also store and release potential energy. If the torsional stiffness expressed as torque per radian of twist is a constant of K, torsional stiffness expresses as torque per radian twist. Torque per radian of twist. Is a constant K, and if theta is the angle of twist, then the resistant torque M theta, the potential energy becomes d theta, which is analogous to the expression for linear extension spring. The unit of potential energy are same as those of work units in SI, joule, and in US customary is foot pump. There is another potential energy which is gravitational potential energy.